Good day, everybody. This is Chris back again with the Ancient Scholar, and today this is let's see, this is video 10 already on just talking about the basics of some of the biological receptors. And today I'm going to move away from nicotinic or cholinergic receptors, primarily acetylcholine, and we're going to talk about catecholamines. And of course, we talked about how the catecholamines and catecholamine-like molecules can activate sympathetic receptors such as alpha and beta receptors. And I want to ask a similar question: how do I, once that either the neurotransmitter or a catecholamine-like neurotransmitter or hormone or even a medication that's chemically similar to catecholamine, how do I deactivate that and get that particular receptor to in essence shut off? Well, when it comes to catecholamines, it's a little bit more complicated than acetylcholine. And I'm not actually going to go into every little detail, but I want to talk about the two major enzymes that we run into. And the two major enzymes are one known as catechol-O-methyltransferase. Let's see if I can spell that. So C-A-T E-C-H-O-L, catechol-O, methyl, M-E-T-H-Y-L, transferase, transferase. And what do you know? It ends with ASE, so you can bet it's an enzyme, and it certainly is an enzyme. We typically will call this COMT, COMT, and that's generally the accepted abbreviation for catechol-O-methyltransferase. The other enzyme, common enzyme that we talk about is something called monoamine oxidase, and that's M-O-N-O-A-M-I-N-E, monoamine oxidase. Okay, again, it's an enzyme, and we typically abbreviate that MAO, MAO. How about I just do that again? A little dyslexia today, apparently. MAO, monoamine oxidase. Okay, now when we look at the names, again, the names tell us a little bit about what these do. For example, catechol-O-methyltransferase. Well, catechol, of course, refers to the catechol nucleus of the adrenergic-like molecule, or the benzene ring, and then O-methyltransferase. Well, basically what this does is it transfers, or helps transfer a methyl group to the catechol nucleus of the molecule. Monoamine oxidase has something to do with the amine, okay, the amine side chain, and it involves an oxidation reaction. Okay, so we actually can kind of get a basic idea of how these work by just looking at them, but let's go ahead and let me just go ahead and draw you a catecholamine. And I'll draw a relatively simple one here. I'm going to draw a molecule called dopamine. Dopamine is typically a neurotransmitter. It's found in the central nervous system. And it's actually medication we can administer as well. And when administered as a medication, it mimics some of the sympathetic effects. It increases the blood pressure, can increase the heart rate, and so on and so forth. In the central nervous system, dopamine plays an important role in regulating mood to some extent. It's also important when we talk about fine motor coordination, movement, and in fact, a deficiency of dopamine is one of the problems that we run into with Parkinson's disease and other disorders like that. But here I have my catechol nucleus. I have my two hydroxyl groups that come off of that. Of course, we can, there's a resonance structure as well to that. And then we'll just kind of abbreviate this a little bit in H2, okay, like that. So that's the what the dopamine molecule looks like. All right. And so, let's say this dopamine molecule is attached to an alpha-1 receptor, we'll say, and I have a vessel that is maybe constricted. And so now I want to ask, well, how does the body kind of, in essence, kind of regulate that a little bit, shut that off? Well, that can happen in, or we can start the whole thing off by either looking at catechol-O-methyltransferase or monoamine oxidase, MAO. So what happens is COMT is simply going to transfer a methyl group to the dopamine, and that methyl group will actually be transferred right here. So when that occurs, we'll just do a different color. When that occurs, I'm going to have a molecule that looks like this, CH3 or H3C. That's my methyl group there that's been transferred, and then I'll have my oxygen, and then of course I'm going to have my catechol nucleus and the rest of the structure. But really what it is it's this right here is a critical thing that COMT does, transfers that methyl group to the dopamine, and of course that helps deactivate it, and there are obviously other things that occur. Monoamine oxidase does something a little different. So if COMT works here, monoamine, well, amine has to do with the nitrogen, so we know that MAO needs to do something here, okay, MAO, monoamine oxidase. And in fact, what we do is, so let me just draw this again real quick for you guys. All right, so there's my dopamine molecule. Let me draw my two hydroxyl groups, HO and HO. Okay, and then these, these are carbons, of course. And so what happens here is I have something that kind of looks like this. Actually, I should probably get rid of that because that little part is altered somewhat. And MAO, of course, changes the amine side chain a little bit, and I get something where I have a hydroxyl group here. I use OH and HO kind of interchangeably, and then I have a double bond O here. So you can see that this group is kind of been cleaved off as a result of that. And then, of course, other steps, of course, occur there. That involve the breakdown. But these are the major first steps that we run into with COMT and MAO, monoamine oxidase. So these are some of the really important enzymes involved in the breakdown of catecholamines and catecholamine-like molecules. Okay, guys, hopefully you found this helpful, and as always, thanks for hanging in there.